Hi, hello everyone. I am back with the end of our notes on ionic and metallic bonding. Remember, so far we have looked at binary ionic compounds. So first we looked at naming ions, naming our positively charged ions, where it just got to be the name of the element or the name of an element with a Roman numeral if it was a transition metal. And then naming our anions, you take the root of the name, you change the ending to "ide," so oxygen becomes oxide. And so now what we're going to do is we're going to add in our last section. You started to investigate this in your POGO packet this week, looking at polyatomic ions. And so we're going to jump right in. We're going to look at the different classifications of polyatomic ions, and then I'm going to very briefly show you how to make a compound with them and how to name them, and then I'll introduce your activity for the week. So we talk about polyatomic ion naming. So first and foremost, a polyatomic ion is going to be a charged group of atoms that are bonded together. And the important thing to note is that the charge applies to the entire group of atoms. So see here we have the nitrate ion. It has one oxygen or one nitrogen and three oxygens. These are covalently bonded together. And then we see this negative charge. Now, that negative charge applies to the entire compound. So the negative charge is not on the nitrogen, it's not on the oxygen, it's on the entire thing combined. So that will influence then how we make compounds with our polyatomic ions. Now, I'm going to go through the different groups. You are not responsible for memorizing the different groups. You will have this PowerPoint, and I'm going to give you an additional chart that just gives you the names of every single one of your polyatomic ions. This first group are some ones that don't actually follow any of our rules. So I just kind of separate them. The first one is the OH with a -1 charge. This is the hydroxide ion. Cn with a -1 charge is going to be our cyanide ion. And then our only positive polyatomic ion that we're going to be working with is the ammonium ion. So that entire NH4 has a +1 charge. And you guys have actually drawn all three of these when we drew our covalently bonded compounds. Then we have a huge group called oxyanions. Now, all of these are going to be negatively charged ions, so they're anions, and they're all going to contain oxygen. Okay, all of these are -1 charges. Chlorate, acetate is a weird one, nitrate, fluorate, and bromate. Now, my slide kind of went through the bottom, so just know that anything that chlorine can do, all of your other halogens can do as well. So chlorate, you're going to have fluorate, and you're going to have bromate, and you're going to have iodate, and they're all going to be relatively similar. We also have a group that has -2 charges. These are going to be our carbonate, our sulfate, chromate, and dichromate. And then -3 are going to be our phosphate ions. Okay, so notice so far in these oxyanions, all of them have ended in 8. So these are going to be what we call our base polyatomic ions. And now what we're going to do is we're just going to fiddle around with them. So our second set of polyatomic ions would be, what if we took one oxygen away, right? So we started with chlorate on our last group, and it was ClO3 with a -1 charge. So we look at our first example on this slide, I have ClO2 with a -1 charge. So all I did was take away an oxygen, so I changed my ending to "ite." So this is the chlorite, then the nitrate, sulfite, and phosphite. Okay, they have the same exact charges as their previous, kind of like sibling ions. They just have one less oxygen. Okay? We also have this very interesting thing that only your halogens can do, right? So if we look at these examples, ClO3 with a -1 charge is chlorate. We've named it. ClO2 with a -1 charge is chlorite. We've also named that. But our halogens can actually make two additional polyatomic ions. We can have the perchlorate ion. Per means more than. So when we add it to chlorate, we have more than chlorate. So we have to have 4 oxygens. Okay? Hypo means less than. So if I write hypochlorite, I write less than the ite. Our ite normally has 2, so hypochlorite only has 1 oxygen. This only happens for our halogens, but it actually happens for all of them, right? So I can see perbromate or hypofluorite. Okay? And our last group would be, what if you added a hydrogen to your oxyanions? Now, notice that hydrogen has a positive charge. So if you add it to, let's say, phosphate, you're going to change that charge. So when I add it to that PO43 minus, I make hydrogen phosphate. And when I add that hydrogen, notice that the charge went from -3 to -2. In the second example, I'm adding two hydrogens. So my charge goes from -3 to -1, and my name is now dihydrogen phosphate. Okay? So what happens when I want to make compounds, right? So our rules before were figure out the charges, circle the numbers, flip them, and rewrite. And it's the same exact rules for this. Identify the charges, circle them, flip them, rewrite the compound. But now we want to remember that the charge applies to that whole polyatomic, so you might need to use parentheses. For example, right here, I want to make calcium bromate. That's my, goal compound. So I write out my two ions. Calcium, according to my periodic table, is Ca2+. Bromate, I'm going to pull it from my chart, it's BrO3 with a -1 charge. So if I want to make the compound that's at the bottom, I'm going to write out both ions and I'm going to circle their number values. Okay, notice I'm circling 2 and the 1, not the plus and the minus, and I'm going to diagonally flip them down. So that 2 from the calcium is going to go to the bottom outside of the bromate. The 1 from the bromate is going to go to the bottom of the calcium. And notice what I did in my final example is I put the bromate in parentheses because I want to say I need 2 of that whole ion. Okay, I don't want to write CaBrO32. It's a very different compound. Okay, same thing here. I want to make lithium phosphate. Okay, so I'm going to write out my two ions and I'm going to circle their number values. Sorry that that plus got circled. Should just be circling the 1 and I'm going to flip them. So that 3 from the phosphate comes right next to the lithium and we can see that right here. And then this is a 1. So when I put it to the outside of the phosphate, I technically don't need parentheses. Now, if you want to put your polyatomic ions in parentheses all the time, that's fine, if that helps you. Just remember that any number you flip down applies to that whole compound, so you would want parentheses if it's not a 1. Okay? What happens when I want to name them? So naming rules apply, right? I'm going to name the first element. It's always positively charged. So now I have 3 choices. Simple name of the element, sodium, calcium, aluminum, or name of the element of the Roman numeral, gold 3, chromium 2. Or I could have the ammonium polyatomic ion. If I'm going to name my anion, if it's a basic one, chloride, fluoride, bromide. Or I'm going to use the polyatomic ion chart and I'm going to call it hydroxide, chromate. Okay, so see here, I have Na2SO4. So I circle flip my numbers back up. Now, when we circle flip these numbers back up, this 2 is going to go up here, right? And I know that because that's one singular thing there, so that 2 can't apply to it. Here, this 4 is part of my polyatomic, and I know that because there's more than one element. Okay, so I have to be really careful when I unflip these. Okay, so that means there was a 1 here. There's no parentheses, so that's what's going to flip back up to the sodium. So we have Na plus and SO42 minus. I know Na plus is sodium. SO42 minus is sulfate, so I get sodium sulfate. Okay, here, the 1 right here flips to the hydroxide. The 2 goes to the manganese. So I get Mn2 plus, OH minus. I name each piece. Mn is manganese. It's a transition metal, so it becomes manganese 2. OH minus for my polyatomic ion chart is hydroxide. So I write hydroxide and then I combine them, manganese 2, hydroxide. And that's it. So we're adding slightly more complicated, well, let's take it back. It's a lot more complicated to work with the polyatomic ions, but our rules are the same. Okay? I'm now going to show you how to do your work for this week.